I'm currently in Austria, in the Eastern Alps, and behind me is the Grunloch Valley, or the Grunloch Sinkhole. This seems like the perfect place to set up a tent, right? A lovely meadow with a short grass and over some trees to the sides which will protect you from the wind. But it turns out that this valley in particular is extremely dangerous to sleep in because it gets deceptively cold. And with that I mean extremely cold, because the lowest recorded temperature over here, in fact there's a measuring station over there down at the bottom, is minus 52.6 degrees Celsius. In fact, it's just a few degrees higher than the lowest recorded temperature ever in whole Europe, which was recorded in Russia, Siberia, which is minus 58.1 degrees Celsius. It could, in theory, be explained by altitude, right? Because this valley is, after all, pretty high up in the mountains, sitting at 1,300 meters of elevation. However, that doesn't explain it either, because the lowest recorded temperature in Austria outside of this place is at 3,100 meters of elevation, and it's only minus 37 degrees Celsius. So that's a much higher temperature at much higher altitudes. So what gives? This is a very unique place, because the temperature difference here between that point down at the bottom of the valley and that point up higher in those trees can be as high as 30 degrees Celsius, which to me just seems insane. Towards the end of the video, I'll be staying in this valley myself overnight to measure the temperature differences myself and essentially to see how it feels like staying here in real life. But before we do that, I'll explain why the temperature difference is happening in the first place. First of all, big shout out to Casual Earth for making a video about this topic 4 years ago, where I actually learned about this interesting phenomenon. Now, the main reason why you get these huge differences in temperature is because of cold air pools. When you cool a big mass of air, it tends to fall down, usually lower in valleys, just because of basic physics. So the main difference between cold air and hot air is that in cold air, the molecules are closer to each other, and in hot air, they are further away from each other. This means that in the same amount of space, cold air has more molecules inside of it, which means that it's more dense and more heavier, and it just tends to fall down because of basic physics. I'm going to demonstrate this with a quick experiment. Here I have 2 glasses of water, one with hot water, which I've dyed with a red dye, and the second one with cold water, which I've dyed with a blue dye. And in both of these containers, the water is in room temperature. Now watch what happens when I add some hot water. It mostly stays at the top part because warm water is lighter compared to the room water temperature that's inside of this container. Now let's add the cold blue water. Because it's colder than the room temperature water, it's heavier and more dense, so it falls down to the lower parts of the container because of gravity. The same thing happens when you mix cold air with warm air. The cold air falls down while the warm air is being pushed up. Every evening when the sun sets, it stops warming up the ground, so the ground becomes more cold and it makes the air above it colder as well, which essentially introduces a very big mass of cold air. Now, when we introduce some mountains and valleys to the same equation, things become a bit more interesting. Because cold air is heavier, it flows down the mountain to the bottom of the valleys just like regular rainwater would. That's why when you're hiking in the mountains and you happen to be at the bottom of a valley after the sun has set, the air cools down much quicker and it cools down to lower temperatures compared to the surrounding area. Now watch what happens when we introduce a depression, or essentially a big hole somewhere along the slope of the mountain. All of the cold air tends to pool up in this hole all the way up to the highest sides of it because it always wants to take the lowest path possible. And the hot air doesn't mix with it because it wants to always take the highest path possible. And the deeper the hole is, the colder it is at the bottom because it has fewer possibilities to mix with the warm air above it. The Grunloch sinkhole is the perfect example of a cold air pool because it's very deep, it's very wide, it's very high up in altitude, so the temperature differences there can be very big, even upwards of 30 degrees Celsius or even more. You can actually see this just by looking at the trees within this sinkhole. As you get closer towards the bottom, they get smaller and shorter because they can't survive the extreme temperatures during the winter. Essentially, it's a reversed tree line because if you flip the image upside down, it looks just like a regular tree line. Now, coming back to sinkholes, the Grunloch isn't the only cold air pool sinkhole in the world. Far from it, actually. There are many examples of this all across the world. You can pretty much find a similar sinkhole in any mountain range across the world. I saw a very similar sinkhole while hiking recently in Slovenia near the Triglav mountain at roughly 2,000 meters of elevation. Notice that here as well, you can see the reverse tree line with very small trees at the bottom, and they progressively get higher as you go up higher. There's also one other popular place here in Central Italy called Campo Felice, where we very frequently during the winters get some of the lowest recorded temperatures here in central Italy. And in fact, I'm actually filming here. You can see it just behind me. Just like the Grunloch, this sinkhole is also about 50 meters in depth, but the only difference is that it's much wider. The lowest recorded temperature here was minus 37.4 degrees Celsius, despite this being only 100 kilometers away from Rome, which rarely gets any snowfall at all. If you're hiking in the mountains, you have to learn how to recognize places like these and ideally avoid setting up your tent right at the bottom of valleys unless you're prepared for those extremely cold temperatures. So in this example, I wouldn't want to set up my tent right at the bottom of this valley, and instead I would want to set it up a bit higher, preferably somewhere over here where those trees start. And lastly, I wanted to say that these extreme temperature differences only happen under ideal circumstances. There can't be any wind, there can't be any clouds in the sky during the night, and also ideally there has to be snow on the ground. In these circumstances, the cold air gets trapped down at the bottom of these holes much better. In all other situations, the temperature difference won't be as high, and overall it will be a bit more manageable. You only get these extremely high temperature differences if the air is completely trapped inside of this valley, like for example it is in the Grunloch Valley, which can see a temperature difference upwards of 30 degrees Celsius. We left our car down there, and the only way to get to the Grunloch Valley is to climb up that mountain over there. So let's do that. After 2 hours and 30 minutes of hiking, it took a bit longer than expected. We finally reached the valley. It's just down there. So to measure the temperature, I have two digital thermometers that save the temperature inside of these devices. I'm going to be setting up one of these thermometers down there at the valley and another one over here a bit higher up so that we can compare the difference. So I'm going to be setting up the first thermometer over here, just underneath this tree. Behind me there already is a measuring station, much more advanced than my little thermometer, because this is a very interesting place and you definitely want to measure a lot of stuff over here. But yeah, I'm going to be setting up my thermometer over here, right next to it. Just before coming here, I checked the weather forecast and it showed that the temperature is going to drop down to 10 degrees Celsius at this altitude, but towards the morning, definitely not now. It's also getting pretty humid here and I have to keep using this rag to clean the lens of the camera. There's also quite a bit of deer over there in that tree line. We saw some of them, but they're yelling and making these loud noises all the time. In fact, the thermometer is just over there, so let's just go and check what the temperature is right now. All right, so the current temperature is 7.1 degrees Celsius with 90% relative humidity. And remember that it was supposed to be 10 degrees Celsius in the morning. The sun has set only 30 minutes ago and it's already below that. So it's definitely going to be interesting. As you can see, the sun has already set. 20 minutes later, it's now completely dark. I just want to say that tonight we're not going to be setting up our tent because wild camping is legal here in Austria. However, I did take off my gear over here just to show you that we have prepared. We have prepared for temperatures maybe down to minus 10 degrees Celsius, not much lower than that. So I hope that the temperature is not going to be dropping down below that. All right, we've now tucked into our sleep systems. It is pretty cold, but now that we're underneath our sleeping bags, we're both pretty warm, I would say. And yeah, I think I'm going to wake up in a few hours. I've set up an alarm to go and check the temperature. Currently going to check the temperature. Here's the thermometer. So I just checked the temperature here on my phone and it's actually just above freezing. It's currently 1 degree Celsius above freezing. So yeah, it's low, but it's actually not that low. Good morning, everyone. It's now 6:30 in the morning, so the sun is slowly rising up as I'm speaking, and now I'm going to be checking the temperatures on both of these thermometers. However, before I do that, I first wanted to show you For context, that the first thermometer is set down here and the second one is up there, somewhere in those trees over there. So really, it's not a big difference at all. It's maybe 30-40 meters of elevation difference, so they're pretty much next to each other. I can definitely see that there's some frost on the ground, so I would guess that it's below freezing. And the temperature is minus 1.6 degrees currently, with a 97% of relative humidity. And up here it's 9 degrees Celsius, currently with a 79% relative humidity. So that's pretty much a 10-degree difference. But one thing that I didn't expect is the relative humidity. So here it's roughly 80% and down there it was 95, almost 100%. So it's much more humid there as well, in addition to being cold. So the main idea for this video was to show you what the temperature difference can be like if you set up your tent further down at the valley compared to a bit further up, especially if it's a sinkhole like this one. Anyway, thank you for watching the video. I hope you learned something new, and if you want to see me in the future again, make sure to subscribe. Bye!